Welcome to Mathenatic. We are busy with June 2024, paper 1, and we are starting with question 1. Question 1.1.1. Here we have 3x squared plus 5x equal to 0, and we want to solve for x. So what I realize is that in these two terms, I have a common factor of x. So I'll factorize out the x, and that means in the first term I'm left with 3x, and in the second term simply 5, and that is equal to 0. Now I use the zero factor rule where I set every factor equal to 0. So my solutions for x are x is equal to 0, or 3x plus 5 is equal to 0. And when I solve for x now, I have x is equals to negative 5 over 3, because I take the 5 to the right hand side and then I divide by 3. Question 1.1.2. Here we have 4x squared plus 3x minus 5 equal to 0, and it says answers correct to 2 decimal places. So we want to solve x correct to 2 decimal places. Now that's an indication that you would need to use the quadratic formula, which you can find on your formula sheet. So the a value from our quadratic formula is the coefficient of x squared. The b value would be the coefficient of x, and the c value would be negative 5, the constant value. So when I substitute, I have negative plus 3 plus minus b squared, which is plus 3 squared, minus 4 times a, which is also 4, and c, which is negative 5, and that's underneath the square root, over 2 times 4, which is the a value. And when I simplify by using my calculator, I have x is equals to 0.8, or x is equal to negative 1.55. Question 1.1.3. Here we have x minus 1 squared minus 9 bigger or equal to 0. Now there are 2 ways to solve this. The shorter way would be to identify that this first bracket is a square, and that 9 is a square number as well. So I can say x minus 1 minus 3 times x minus 1 plus 3. So I identify the difference of 2 squares. But that is a little bit complicated for most students. So let us take a little bit more of a natural approach. So naturally, we want to multiply out those brackets. So when I expand, I have x squared minus 2x plus 1 minus 9 is bigger or equal to 0. Then I add my like terms together, and that is x squared minus 2x minus 8. Now what I can do is I can factorize this trinomial, and I hope you have practiced your factorization. So I'll have x and 4 and x and 2. This will create the 8. So 4 times 2 would be the 8. But I need a negative 2x in the middle. So I'll have x minus 4 and x plus 2. So look, when I factorize, it's minus 4 times plus 2 will give me minus 8. But minus 4x plus 2x will give me negative 2x. That leads me to 2 critical values of x is equal to 4 and x is equal to negative 2. Now what I prefer to do is use a number line, and I draw a quick parabola on the number line, because this is a parabola, and the x-intercept of that parabola is negative 2 and plus 4. And I'm looking on the parabola where the parabola would be bigger or equal to 0. So can you see to the right side of plus 4, the parabola is above the x-axis, so it's bigger or equal to 0. And to the left of negative 2, it is also above the x-axis, where it will be positive. So therefore, we can say x is smaller or equal to negative 2. So I'm moving towards the left of negative 2. And x is bigger or equal to 4. So I move towards the right of 4, because that is where the parabola is above 0. Question 1.1.4. Here we have 5 to the power of 2x minus 5x is equal to 0, and we want to solve for x. What I recommend you do is replace 5 to the power of x with k. So we can say, let k be equals to 5 to the power of x. And then we can rewrite the equation as k squared minus k is equal to 0. Now I can see there's a common factor of k. So I factorize out the k, and I have k minus 1 in brackets. And then I solve the equation in terms of k. So I set k equal to 0 and k minus 1 equal to 0. So I have k equals to 0 or k minus 1 equal to 0. So therefore k can be 0 or 1, but this does not solve for x. So what I need to do is I replace k with 5 to the power of x. So I have 5 to the power of x is equals to 0, or 5 to the power of x is equal to 1. Now, there's no way of writing 0 as 5 to the power of something. So there is no solution on the left-hand side. But on the right-hand side, I can rewrite 1 as 5 to the power of 0. So I'm writing 1 as 5 to the power of 0, and I can see that x is equal to 0. So therefore, x is equal to 0. Question 1.1.5. Here we have x divided by the root of 20 minus x is equal to 1. So what I'll do first is I'll cross multiply to have x equals to 20 minus x. So what I'm doing is I'm taking the denominator and I'm multiplying that with 1, and that leads me to x equals to 1 times the root of 20 minus x. Next, I'll take the square on both sides to get rid of the square root. So that leads me to x squared on the left is equal to 20 minus x. Because when you square a square root, you are left with the contents of that square root. Now I'll write the equation in standard form. So I'll have x squared plus x minus 20 is equal to 0. And this is an easy trinomial that I can factorize. So I'll have the factors of x, which is x times x, and the factors of 20, which is 4 and 5, which will lead me to a coefficient of 1 in the middle. So therefore it will be plus 5 and minus 4. So I can have two possible values for x. X would be equal to 4, or x is equal to negative 5. Now it's important with square root questions to always check your answer. So what I mean by that is you take 4 and you substitute it into the original equation to see if it will be equal to 1. So we'll have 4 divided by 20 minus 4, which is the root of 16, and that is 4 over root of 16, which leads me to 1. So the left-hand side is equal to the right-hand side. Therefore, x can be equal to 4. Now let us test negative 5. So if I put in negative 5 in the place of x, it will lead me to negative 5 over the root of 25, which leads to negative 1. But negative 1 is not equal to positive 1. So therefore, x cannot be equal to negative 5. So remember to check your values in the original equation. You can also use your calculator to do this. Question 1.2. Here we want to solve x and y simultaneously. We are given two equations. In the first, we have x plus y equal to 9. And in the second, 2x squared minus y squared is equal to 7. So what I would like to do is I'm going to rewrite the first equation, and I'll have x as 9 minus y. So I'm solving the equation in terms of x by moving the y to the right-hand side. Now I'll take this x and 9 minus y, and I substitute it into my second equation. So I'll have 2 times x, which is 9 minus y squared, minus y squared is equal to 7. Notice that I'm using brackets to show the substitution, and I'm squaring the full bracket. So now I need to do a little bit of algebra. Let's expand the bracket. So I'll have 2 times 81 minus 18y plus y squared minus y squared is equal to 7. So remember, 9 minus y squared expands to 9 minus y times 9 minus y, and then you need to FOIL properly. Now let me multiply the 2 in. So I'll have 162 minus 36y plus 2y squared minus y squared is equal to 7. And if I rewrite the equation in standard form, I see that I have 2y squared minus y squared, which simplifies to y squared. Next, we have negative 36y, and there are no other like terms. And then I'll have 162 minus 7. So I'll bring the 7 to the left-hand side. And that becomes plus 155 is equal to 0. Now, normally here, people would use the quadratic equation to solve y. But if you're comfortable, you can always try to factorize this as well. So the factors of y would be y times y, and the factors of 155, that gives me 36, would be 31 times 5. That gives me 155, and I need to have minus 36 in the middle, so it's minus 31 minus 5. Therefore, y would be equal to 31, or y would be equal to 5. And now I have my equation for x, which is 9 minus y. So we'll have 9 minus 31, or x is equals to 9 minus 5. So that leads me to an x value of negative 22, or an x value of plus 4. Question 1.3. Now this is our problem solving question in question 1 of paper 1. What I recommend is, if you are intimidated by this question, that you rather leave some space open on your question paper and move on to the questions that are a little bit more familiar to you. You can always come back and try and answer this question. So here we are given that P is equals to 1 minus A, and T is 1 plus A times 1 plus A squared plus 1 plus A to the power 4, all the way to 1 plus A to the power of 512. These ellipses mean that this pattern continues all the way up until this last bracket. And it says determine the value of P times T in terms of A. So let us start with that. We'll have P times T, and that is equals to 1 minus A times 1 plus A, 1 plus A squared, and that continues all the way to 1 plus A to the power of 512. And if I focus on the first two brackets, I notice that that creates a difference of 2 squares. So that will become 1 minus A squared times 1 plus a squared times 1 plus a to the power of 4, all the way to 1 plus a to the power of 512. And can you see that from our first result, we'll also create another difference of two squares. So let's do that quickly. We'll have 1 minus a to the power of 4 as the result of the first two brackets times 1 plus a to the power of 4, and that continues all the way to the last bracket. So what I'm noticing is if I multiply p with t, the first two brackets create a difference of two squares. Then if I take that result and I multiply it with the next bracket, which is 1 plus a squared, I also have a difference of two squares. And that will continue all the way up until the last bracket. So I'm spotting a little pattern here. That means my last set of brackets would be 1 minus a to the power of 512 times 1 plus a to the power of 512. And if I expand this difference of two squares, I have 1 minus a to the power of 1024. And now I have simplified p times t in terms of a to two terms. So in terms of the mathematics, it's not too difficult. It's all about seeing the pattern and then following that pattern through and making a proper conclusion. But like I said, if you are struggling with these type of questions, rather leave them out and move on. You can always come back at the end of your exam. Thank you for watching. Remember to show your support by hitting the like button and subscribing to Mathenatic. We are moving on with question 2 of June 2024, paper 1. Question 2.1. Consider the geometric series 4 plus 2 plus 1 plus a half, and that pattern continues. The first question is, does the series converge? So if it is a geometric series, we know that it has to have a common ratio of r. And convergence is about finding r, and if r is in between 1 and -1, then we can say the series converges. So let us find the constant ratio. So we'll have r is equals to the second term, which is 2 divided by 4, and that is a half. And let us just test our answer. So I take the third term, which is 1, and I divide that by 2, and I can see that the ratio is constant, and therefore the ratio is in between 1 and -1, so we can say that the series converges. The second question says, calculate the sum to infinity. So in order for us to have the sum to infinity, the series actually needs to converge. That is one of the prerequisites of the sum to infinity. But to answer the second question, we say the sum to infinity is equal to a over 1 minus r. And you can find this formula on your formula sheet. Now a is the first term, which is 4, and r is the ratio of a half. So when I substitute, I have 4 divided by 1 minus a half. And if I put this in my calculator, I have the sum to infinity is equal to 8. But remember, the sum to infinity cannot exist if the series does not converge. Question 2.2. Given the sigma notation with the lower limit of p equals to k to the upper limit of 10, and we're taking the sum of 3 to the power of p minus 1 is equal to 29,520. Calculate the value of k. So we'll start by finding the first few terms in this series. So I'll substitute p with k. So the first term would be 3 to the power of k minus 1. And I'll add it to the second term, which is 3 to the power of k plus 1 minus 1. Because the first term in the series is k, the term after k would be k plus 1. So that'll be the second term. And the third term would be k plus 2, and the fourth term k plus 3, and so on. So the third term we'll have 3 to the power of k plus 2 minus 1. And our fourth term would be 3 to the power of k plus 3 minus 1. So can you see, every time that I replace k, for the next term I simply add 1. And this continues all the way up until our last term of 10. So if I simplify this, I have 3 to the power of k minus 1 plus 3 to the power of k plus 3 to the power of k plus 1 plus 3 to the power of k plus 2. And this pattern continues. Now, I know that this is a geometric sequence, a geometric series, because we are raising it to the power of something. So that means we have a constant ratio. So to find the constant ratio, I'll have r is equal to 3 to the power of k divided by 3 to the power of k minus 1. And if I simplify this, I have 3 to the power of k minus 1. So remember, I'm using my laws of exponents where I subtract the exponents from each other. So that becomes 3 to the power of k minus k plus 1, which is simply 3 to the power of 1, or 3. So our constant ratio between terms would be 3. Next, because I want to calculate k, and I am given the result of the sigma notation, I know that this result is the result of the sum of the series. So it's Sn. So I want to find how many terms are in this pattern. So we have Sn. We are looking for the number of terms n. So in sigma notation, the number of terms would be the top value minus the bottom value plus 1. So it'll be 10 minus k plus 1, and that becomes 11 minus k. So our number of terms would be 11 minus k. So I have an r value, I have a first term, which would be a, and I have an n value. That allows me to find Sn. So because this is a geometric series, I look at my formula sheet, and Sn is a times r to the power of n minus 1 over r minus 1. So you can find this on your formula sheet. Now we have Sn as 29,520. So let us substitute that. So it's 29,520. The a value is the first term, so it's 3 to the power of k minus 1. The r is 3, and the n value is 11 minus k. So we have r raised to the power of 11 minus k minus 1. And below the line, we have r, which is 3 minus 1. Now the mathematics looks a little bit daunting from here. So what we need to do is we need to solve for k from this equation. But can you see, there's quite a little bit of work that needs to go into setting up the equation. We first need to find the first few terms of our geometric series, then establish what r is, and then find n. And now we're going to substitute it into Sn. So let us continue from here. 3 minus 1 is equals to 2. And I can get rid of this 2 by multiplying it with 29,520. And that simplifies to 59,040, which is equals to 3 to the power of k minus 1 times 3 to the power of 11 minus k minus 1. Now, I'm going to get rid of this bracket because there's nothing else for me to do. so I need to multiply out. So let's do that quickly. We have 59,040 is equals to 3 times k minus 1 plus 11 minus k minus 1 times 3 to the power of k minus 1. So what I'm doing is I'm multiplying 3 to the power of k minus 1 with the first term, and because the bases are the same, I add the exponents together. And for the second term, I simply multiply negative 1 with 3 to the power of k minus 1. So if I simplify further, I have 3 to the power of 10 minus 3 to the power of k minus 1. So can you see that in the first term here, k minus k would become 0, so I'm left with 3 to the power of 10. Now there are different ways to approach this. You can, if you want to, take 3 to the power of 10, leave it on this side, move 3 to the power of k minus 1 to the right hand side, so let's do that. And I have 3 to the power of 10, and I subtract 59,040 from that. And when I use my calculator, I get 3 to the power of 10 minus 59,040 is equal to 9. And now it's pretty simple. I can rewrite 9 as 3 to the power of 2, and I have 3 to the power of k minus 1 on the left. So therefore, k minus 1 is equal to 2, and therefore k would be equal to 3. So like I said, setting up the equation is a little bit daunting, and from there, you need to just go through it methodically. So we need to get rid of the denominator by multiplying, then get rid of the brackets by multiplying out. Then you are left with two terms. So what I'm doing is I'm taking the term of k to the left and the term of numbers to the right. Then I simplify using my calculator, and from here on out it's pretty simple to solve. We want to write the bases both as free, and therefore we can solve for k. Thank you for watching. Remember to show your support by hitting the like button and subscribing to Mathenatic. We are going on with question 3 of June 2024, paper 1. Question 3.1. Consider the quadratic number pattern of 3, 7, and 12. Show that the general term of this number pattern is given by Tn is equal to a half n squared plus 5 over 2n. When they say show, it actually means calculate. You are not allowed to simply substitute n with 1 and then show that term 1 is equal to 3, or substitute n with 2 and show that term 2 is equal to 7. So for the first question, we have the pattern of 3, 7, and 12. The first differences is 3 to 7 is 4, and 7 to 12 is 5. And then the second differences, so from 4 to 5, I need to add 1. Now remember that 1 would be equal to 2a, the 4 would be equals to 3a plus b, and the 3 would be equal to a plus b plus c. So now we can solve a, b, and c. So 2a is equals to 1, therefore a is equals to a half. 3 times a half plus b is equal to 4. So when I solve b, I have 4 minus 3 over 2, and that becomes 5 over 2. And a plus b plus c is equal to 3. So I have a half plus 5 over 2 plus c is equal to 3. And when I simplify, I have 3 plus c is equal to 3, therefore c is equal to 0. So therefore, the general term is an squared plus bn plus c. And a's value is a half, and b's value is 5 over 2, and C is simply 0, so we don't have to say plus 0. The second question says, what number must be added to Tn minus 1 so that Tn is equal to 13,527? So what I would like to do is find the position of 13,527. So we know that's part of the pattern, and I set Tn as equals to a half n squared plus 5 over 2n. So I'm replacing that Tn with our equation. Now I'm going to solve for n. So I'm going to multiply everywhere by 2, and that becomes 27,054 is equals to n squared plus 5n. So when I multiply by 2, it gets rid of the half and it gets rid of the 5 over 2, so the denominators of 2. Next, I can write this in standard form. So we have 0 is equals to n squared plus 5n minus 27,054. Now I will use my calculator to solve for n. So n is equals to 162, or n is equals to negative 167. Now because this is a number pattern, we know that n, which is a position in the number pattern, cannot be negative. So therefore, n is equals to 162. That means that term 162 would be equals to 13,527. Now the question said, what must be added to Tn minus 1 so that Tn is equals to that value? So we found the position of Tn. Now we need to find the value of Tn minus 1. So that's the term before Tn. So if Tn is 162, or term number 162, then term n minus 1 would be term 161. What I can do now is I substitute n with 161 in my original formula. So that gives me 13,363. And the question said, what must be added to term 161 to get to 13,527? So I simply take the difference between the two terms. So it is 13,527 minus 13,363, and that is 164. So I need to add 164 to Tn minus 1 to get to Tn. Question 3.2. Given an arithmetic sequence with term 1 is equal to 8 and term 2 is equal to 11, calculate the value of n if Tn is equal to 41. So if term 1 is equal to 8, then we have the a value as 8. And if term 2 is 11, we have the constant difference, because that's what arithmetic sequence means. So the constant difference is term 2 minus term 1, and that is equals to 3. So from our formula sheet, we have Tn is equals to a plus n minus 1 d. And we want to find n. So Tn is equals to 41, a is equals to 8, n minus 1 times 3. So if I take the 8 over, I have 41 minus 8, which is 33, is equals to n minus 1 times 3. Then I can divide both sides by 3. So 33 divided by 3 becomes 11, is equals to n minus 1. And therefore n is equal to 12. 3.2.2. A new arithmetic sequence P is formed using the term position and term value of the given arithmetic sequence. For the new sequence, P8 is equals to 1 and P11 is equals to 2, and so forth. Write down the value of P41. So in the previous question, we found that term 12 is equal to 41. So what I simply need to do is swap these two numbers. So P41 would be equal to 12. Question B reads, calculate the value of the first term of the new arithmetic sequence. So they tell us that the sequence is arithmetic, so we know that it has a constant difference between terms. We know that term 8 is equal to 1, that term 11 is equal to 2, or sorry, we can make it P11, and that P of 41 is equal to 12. So P is the notation they use in place of T. So that's term 8, term 11, and term 41. So if our rule for an arithmetic sequence is Tn is equals to a plus n minus 1d, and we replace t with p, then Pn is equals to a plus n minus 1d. And with this information, they want us to calculate the first term, so we need to find the a value. So let me substitute that information into P8. So P8 is equals to 1. I don't know what a is, plus n minus 1 d, but we know that n is equals to 8 because that's the 8th term. So if I simplify, I have 1 is equals to a plus 7d. Let me do the same for P11 or term 11. I know that term 11 is equals to 2. I don't know the a value. I know that n is 11, so it's 11 minus 1 times d. So therefore, we have 2 is equals to a plus 10d. And can you see, we now have two linear equations. And what we can do is solve these equations simultaneously. So I can see that a would be equals to 1 minus 7d in the first equation, and in the second equation 2 minus 10d would be equal to a. So now I have two equations for a, and if the a value is the same, that means that 1 minus 7d would be equals to 2 minus 10d, and if I solve for d, I have 2 minus 1 is equals to 10d minus 7d, therefore 3d is 1, so d is equal to a third. And I take that value of d and I substitute it into any one of the two equations for a. So it's 1 minus 7 times d, so therefore a is negative 4 over 3. So the question is a little bit tricky because they give us t in the form of p, so we're replacing tn with pn. So that's the first thing that you need to recognize. And the second thing that they do is they take the term number and that becomes the actual value, and they take the value and that becomes the position. From there, you can use simultaneous equations to solve a. Thank you for watching. Remember to show your support by hitting the like button and subscribing to Mathenatic. We are going on with paper 1 of June 2024, and this is question 4. We are given that gx is equals to 1 over x minus 1 plus 2, 4.1. Write down the equations of the asymptotes of g. So remember, the base formula is a over x minus p plus q. The q value represents the horizontal asymptote, and x minus p equal to 0 represents the vertical asymptote. So what we will do is we take x minus p and then we solve for p. So for 4.1, we have a vertical asymptote where x is equal to 1 and a horizontal asymptote where y is equal to 2. 4.2. Draw a graph of G indicating any intercepts with the axes and asymptotes. So we already have the asymptotes, and what we want to do now is find the x and y intercepts. So in order to find the y-intercept, I will make x equal to 0. So therefore we have y is equals to 1 over 0 minus 1 plus 2. And that means that y is equals to 1 when x is equals to 0. And then for the x-intercept, we will make y equal to 0. So 0 is equals to 1 over x minus 1 plus 2. So I'll transpose the 2, so I move it to the other side. And I have 1 over x minus 1 on the right-hand side. Then I will cross multiply, so I'll multiply negative 2 with the denominator. So we'll have negative 2x minus 1, or negative 2 multiplied with x minus 1 is equals to 1. I'll quickly multiply out. So it's negative 2x plus 2 is equals to 1. And then I'll solve for x. So we can see that x is equal to a half. That will be our x-intercept. So let us quickly draw the function. Always draw the x and y axes. Put arrows on your axes and show the origin with a 0. Next, we'll draw the horizontal asymptote and the vertical asymptote. For the horizontal asymptote, y is equal to 2, and for the vertical asymptote, we have x is equal to 1. And can you see I'm not really focused on scale? I just want to have everything in its right position. Next, I'll draw the y-intercept, and that is where y is equals to 1. So on my y-axis, it will go through plus 1. And the x-intercept is where x is equals to a half. So for the hyperbola, we'll have a curve that moves towards the asymptotes. And I'm trying to get my curve to move towards the asymptotes but never touch the asymptotes. And I'll put arrows on my curve. And the same goes for the first quadrant. Now what you can do is you can always substitute a point in on this quadrant or on that curve. And for example, x equals to 2. So put x equals to 2 in your equation to find a reference point. So when x is equal to 2, y would be equal to 3. And all that I'm doing is I'm replacing this x with a 2 to get our y coordinate. So notice at 4.2, I have the y-intercept, the x-intercept, I have the asymptotes, and I have the curves in its right position with one reference point. Question 4.3. Determine the values of x where gx is bigger than 0. So let us look at our sketch. So where gx is bigger than 0 is where the curves are above the x-axis. And can you see that we're above the x-axis for every value to the left of a half? So x would be smaller than 1/2. And we're also above the x-axis for every value to the right of the vertical asymptote. So for question 4.3, it is where x is smaller than 1/2 or where x is bigger than 1. 4.4. Determine the equation of the axis of symmetry of G which has a negative gradient. So for an hyperbola, you'll have two axes of symmetry, one with a positive gradient, so that is y is equals to plus x plus c, and a negative gradient where y is equals to negative x plus c. So remember, the axis of symmetry either has a gradient of positive 1, or when it's negative, the gradient would be equal to negative 1. So if you think of the format of y equals to mx plus c, for a negative gradient, we already have that as negative 1. Now we just need to solve the y-intercept. And in order to do that, you'll take the point where the two asymptotes intersect, because that axis of symmetry will move through that point. So we are going to use the point 1 and 2 in order to solve our y-intercept. For 4.4, we have y is equals to negative x plus c. I'm replacing y with the horizontal asymptote of 2 and x with 1, and then I can solve c. Therefore, the equation of the axis of symmetry with a negative gradient would be y is equals to negative x plus 3. Thank you for watching. Remember to show your support by hitting the like button and subscribing to Mathenatic. Question 5 of Paper 1, June 2024. In the diagram, the graphs of fx is equals to log ax and g are drawn. Graph g is the reflection of f in the line y equals to x. Graph f passes through the point P. Q is the x-intercept of f, and R is the y-intercept of g. So before we start this question, understand that g is a reflection of f through the line y is equal to x. So that means if I reflect this point over the line y equals to x, it will be reflected as 2 and 4. 5.1. Write down the coordinates of P prime, the image of P on G. And that is exactly what I just explained. P prime would be 2 and 4. It's because we're reflecting over the line y equals to x, it means that the x and y values would swap position. 5.2. Show that a is equals to 2. Now, a is the base of our log. So, for 5.2, we are given that fx is equals to log ax. Now, we substitute the point of p, which is 4 and 2, into that equation. So, y is equals to 2 log a, and x is equal to 4. Now, from the theory of logs, if I want to remove the log, I'll take the base of the log and I raise it to the power of 2, and that will be equal to 4. Now, if I take the square root of that, it means that a is equal to 2. Now, normally, when you take the square root, you would say plus minus, and you would consider plus minus 2 for the value of a. But if you remember the rules of logs, the base of the log, so that a value must always be bigger than 0. So I will not consider a equals to negative 2. 5.3. Write down the equation of g in the form of y equals. So if the equation of f is y equals to log 2x, then the equation of g would be y equals to 2 to the power of x. So the inverse function simply becomes what you have here in the log, 2 raised to the power of x. 5.4. T is a point on F in the first quadrant where TR is parallel to the x-axis. Calculate the area of triangle RTP. So can you see on our graph we only have R, but we are told that TR is parallel to the x-axis. So imagine that there's a line going from R towards F, and it meets F at T. So RT is parallel to the x-axis. And then the point T goes to the point P, or P prime. And if I connect those points, I have a little triangle. And it says calculate the area of the triangle. Now the actual question is about finding these coordinates. So we already have P prime. And if we have g as y is equals to 2 to the power of x. That means where x is equals to 0, we'll have 2 to the power of 0, so y is equals to 1. So the coordinate of r would be 0 and 1. And now that I have a y value, I can substitute it into my equation for f, which is y is equals to log 2x, and I can find the x coordinate of t, because we already know that that is parallel. So that means the y value of t is already equal to 1. So let's make y 1 and log 2x. And if I simplify or I solve for x, I have x is equals to 2 to the power of 1. So therefore, the coordinates of t would be x is 2 and the y value is 1. And do you notice that this x coordinate is the same as p prime's coordinate? So that means that this line is parallel to the y-axis. So if this is parallel to the x-axis and that's parallel to the y-axis, this angle would be 90 degrees. And the height of this triangle is the difference of y values. So we'll have 4 minus 1, that is equal to 3. And the length of RT is 2 minus 0. So that is simply 2. Now, let us show all of these calculations for 5.4. So for 5.4, I would say R is 0, 1. Then to find T, what we did is we said y is equals to log 2x, and we made y equals to 1. So therefore, x was equals to 2. Therefore, the coordinates of t is 2 and 1. And then we can say that RT is equals to 2 units and PT is equals to 3 units. Therefore, the area of triangle RTP prime is half of the base times the height, and that is 3 units squared. Thank you for watching. Remember to show your support by hitting the like button and subscribing to Mathenatic. Let's move on to question 6 of Mathematics Paper 1 of June of 2024. The graphs of fx equals to x squared minus 2x and gx equals to mx plus c are drawn below. D and E are the x-intercepts and P is the y-intercept of f. The turning point of f is t1 and negative 4, and the graphs of f and g intersect at P and E. Now, before I attempt the questions, I would like to fill in the information on my diagram. So I know that fx is equals to x squared minus 2x minus 3. The equation of gx was given as mx plus c. We know that P and E are the intercepts and that the coordinates of t is 1 and negative 4. Question 6.1. Write down the range of f. So the range is all the y values for this graph, and I can see that the graph is above negative 4. So for 6.1, the range is y is bigger or equal to negative 4. 6.2, calculate the coordinates of D and E. So the points D and E are the x-intercepts of the graph of f. So we know that at the x-intercepts, y is equal to 0. So we'll have 0 is equals to x squared minus 2x minus 3. And that's an easy trinomial to factorize. So if I split the factors of x squared, I have x, and the factors of 3 is 3 and 1. And I'm trying to create negative 2 in the middle. So my signs would be negative 3 and plus 1. Now if I solve for x, I have x is equal to -1 or x is equal to 3. But the question said calculate the coordinates of D and E. So you'll always want to leave your answer as coordinates. So for D, we have x of -1 and y is 0. And for E, we have x is 3 and the y value is also 0. Now before we continue, I'd like to put that information on my diagram. So I have D as -1 and E as 3. Question 6.3. Determine the equation of G. So we have G is equals to mx plus c. And I can see I can find the c value if I can find the coordinates of P. Now P is the y-intercept of fx. So let us start there. Let's find the coordinates of P. So I'll make x equals to 0 in our fx equation. So it's 0 squared minus 2 times 0 minus 3. And that is equal to -3. Therefore, the coordinates of P is 0 and -3. So therefore, if I have our straight line as y is equals to mx plus c, we have our y-intercept, which is c, as -3. Next, we want to find the gradient of this line. So we can find the gradient by using our gradient formula and using the points E and P. Alternatively, we can substitute x and y with the coordinates of E. So at E, y is 0, x is 3, and we have the y-intercept. So if I simplify, I have 3 is equals to 3m. Therefore, the gradient is equal to 1. So my equation of the line, we have gx is equals to mx plus c. So m is 1 and c is -3. We can also write it as x minus 3. 6.4. Write down the values of x for which fx minus gx is bigger than 0. So if I take the inequality of fx minus gx bigger than 0, I can write it as fx is bigger than gx. So I simply move the gx to the right-hand side of the inequality. And if I look at my function, I'm looking where is fx above gx, and you can see it's to the left of point P. And also fx is above gx to the right of point E. So the x value here to the right of E is x is bigger than 3. And to the left of P is x is smaller than 0. So therefore, x would be smaller than 0 or x would be bigger than 3. Notice I'm not writing this as one inequality, but I'm writing it as two inequalities because I'm going in different directions. 6.5. Determine the maximum vertical distance between h and g if hx is equals to negative fx for x between -2 and 3. So for 6.5, what I would like to do is first find the equation of hx. And that's simply negative fx. So I take fx and I change all of the signs of every term. So that is multiplying the whole equation with -1. So what I realize is that hx is the reflection of fx about the x-axis. So let me draw a rough sketch of that graph in. So it will go through point D and E. And the question says, determine the maximum vertical distance between hx and gx. So can you see in our graph, if I draw in a rough sketch of hx, or h, we're trying to find the maximum vertical distance between h and g, so that's the straight line. And it gives us a restriction. It says where x is between -2 and 3. So we can see that this 3, the upper limit, is already that point of intersection. So I'm guessing that the x value here at our point of intersection on the left would be -2. So in order to find the maximum vertical distance, we would need to find the distance between h and g. So that distance can be represented as hx minus gx. Notice I'm putting hx first because that's the graph above gx. So I'm subtracting gx from that. So let me substitute the equations in. So hx is -x squared plus 2x plus 3 minus gx, which is x minus 3. And notice my use of brackets because I need to subtract the full line. So I have a new equation for the distance or the vertical distance, and that is -x squared plus x plus 6. So when I simplify, I have -x squared plus 2x minus x, that becomes plus x, and then plus 3 minus minus 3, which becomes plus 3, and that's where the plus 6 comes from. Now, if I want to find the maximum distance, I'm going to use calculus. You can also use completing of the square. But if I take the first derivative, that becomes -2x plus 1. And to find the maximum distance, it's where the first derivative would be equal to 0. So I'm solving an x value. So if I solve for x, I have x is equal to a half. Now that half does not represent the maximum distance. It represents the position at which the maximum distance is. And that is where x is equal to a half. Now to find the maximum vertical distance, I take my distance formula and I substitute x with a half. So it's -1/2 squared plus a half plus 6. And when I simplify that, the maximum distance would be 6.25 or 6 1/4. Question 6.6. Given that kx is equals to gx minus n, determine n if k is a tangent to f. So let us start by finding kx. So we know that kx is equals to gx minus n, and the equation of gx is equals to x minus 3. So therefore, the function of kx is equals to x minus 3 minus n. Next, we are given information that k is a tangent to the curve of f. And I want to find the value of n when k is a tangent to the curve. So what I realize is that the line of k would be parallel to the line of g because they have the same gradient of 1. And what I can try and do is use the gradient that is equal to 1 to find this point of intersection. So when I have found this point of intersection, it will allow me to find or to have a y value and an x value on the line of k, which will allow me to solve for n. So if it is a tangent to the curve, we know that the gradient is equals to 1, but we also know that fx is equals to x squared minus 2x minus 3. But gradient can be represented as the first derivative. So the first derivative of fx is 2x minus 2. And we know that the gradient of k is 1. Therefore, the gradient of the tangent to the curve is also 1. So 1 is equals to 2x minus 2, and now I can solve for x. So that becomes 3 is equals to 2x, therefore x is equals to 3 over 2. So at this point of intersection of k to the graph of f, we have x is equals to 3 over 2. Now I need to find the y value. So in order to find the y value, I can use the equation of fx and substitute that x value in the place of x in this equation to find the y value. So we'll have y is equals to 3 over 2 squared minus 2 times 3 over 2 minus 3. And that means that y is equals to negative 3.75. So you can use your calculator. And now we have the coordinates of a point on the line of kx. So we have a y value and an x value, which we can substitute into our equation of kx. So we have kx is y equals to x minus 3 minus n, where the y value is negative 3.75. The x value is 1.5, so it's 1.5 minus 3 minus n. And then I can solve for n. So that becomes negative 3.75 minus 1.5 plus 3 is equals to negative n. So negative n is negative 2.25. Therefore, n is 2.25. Thank you for watching. Remember to show your support by hitting the like button and subscribing to Mathenatic. We are going on with question 7 of paper 1 of June 2024. 7.1. 6 years ago, Tabu bought a phone for 13,000 Rand. The value of the phone depreciated annually according to the reducing balance method. The value of the phone is now 8,337 Rand and 75 cents. Calculate the annual rate of depreciation. So we are given information that we are using the reducing balance method. So that's the one that looks like compound interest. We know that the value of the phone at the start was 13,000 Rand, and the current value of the phone is 8,337 Rand and 75 cents. We don't know the value of I, but we know this happened 6 years ago. So n is equal to 6. So the first thing that I would do is I would divide this amount of 8,000 Rand with 13,000 Rand. And that gives me a decimal value, which is equals to 1 minus I to the power of 6. Now in financial mathematics, you need to keep all the decimal values up until the end of your calculation. Only round off in your answer. Next, I'll take the root of 6 on both sides of the equation. On the right-hand side, I'll be left with 1 minus I, and on the left, another decimal value. Now, in order to solve for I, I'll move I to the right, and that becomes positive I, and I'll move the decimal value to the left. So it will be 1 minus 0.92 and all the decimal values, and that answer becomes 0.0713 with some decimal values. Now, in order to answer the question, they said calculate the annual rate. So I is not the rate. In order to find the rate, I need to multiply I with 100. And that simplifies to 7.14%. 7.2. Eric and Tundi needs to save 80,000 Rand each to go on a holiday at the end of December 2027. Tundi decides that she will start saving at the end of January 2025. she will make 36 monthly deposits into the savings account that pays 8.6% per annum compounded monthly. The deposit will be made at the end of each month. Eric calculates that if he makes 48 deposits of 1,402 Rand starting at the end of January 2024, he will have enough money to go on holiday. He will make his deposits into the savings account at the end of each month. The savings account pays an interest of 8.6% per annum compounded monthly. Calculate the difference between the total amount that Eric and Thandi will deposit into their respective savings account. We know that they want 80,000 Rand somewhere in the future, and the information on Thandi is that she would pay or make 36 deposits, so that is an end value of 36. We don't know the size of her deposits, but we know that her interest rate is 8.6% compounded monthly. Eric will make 48 payments. We know the size of his payments, so that is 1,402 Rand. And he also earns the same amount of interest. Now, to find the total amount that Eric has put into the savings account, we can take his monthly payment times 48. So let's call that Eric, and his total is 48 times 1,402 Rand. So Eric pays 67,310 Rand and 88 cents into his savings account. Now for Thandi, we know that she would save 80,000 Rand. We know the end value, but we don't know what's the size of her deposits. So we first need to find the value of X and then take that answer and multiply that by 36 to get her total payments in the same way as we did with Eric. So let's do Thandi's calculation. Thandi will earn money in the future, so it's a future value annuity. And you can find this formula on your formula sheet. So for the F value, we have 80,000 Rand. We don't know X. We know that I is 8.6%, and that's compounded monthly. Now be careful, the N value is 36. It's not 36 times 12 over our I value of 0.086 divided by 12. So what I do is I take the 8.6% and I convert that to a decimal value, and I divide it by 12 to show the compoundings. Now you can use your calculator to solve for X. So to solve this equation, I have an X value of 1,955 Rand and 78 cents. Therefore, Thandi's total, let's call it Thandi's total, is 1,955 Rand and 78 cents times 36, and that leads to a total of 70,408 Rand and 8 cents. Now let's quickly go back to the question. It says, calculate the difference between the total amount of Eric and Thandi. So we have Eric's total and we have Thandi's total. So the difference is simply the difference between those two values. So we'd say 70,408.08 minus 67,310.88. And our final answer then is 3,097 Rand and 20 cents. 7.3. Lesibana was granted a loan of 225,000 Rand. The rate of interest for the loan is 9% per annum, compounded monthly. Lesibana will make monthly payments of 5,500 Rand, starting exactly 4 months after the loan was granted. How many payments will Lesibana make to settle the loan? So from the question, we know we are working with the P formula from our formula sheet. We have our interest rate of 0.09 divided by 12, so that is I. we have our payments, which is 5,500 Rand. And then we know the starting amount of the loan is 225,000 Rand. But the first payment was only made exactly 4 months after the granting of the loan. And we want to find the number of payments that we need to make. So let us start by writing down the correct formula from our formula sheet. We have P is equals to X multiplied with 1 minus, and in brackets 1 plus I to the power of negative n divided by I. Now we need to be careful. The p-value is not 225,000 Rand, but it's actually 225,000 Rand that earns 3 months of interest. So remember, when you start a payment 4 months after the granting of the loan, the first month creates a little gap. So we have our gap, and then the first payment would be on month 4. So we don't count the first payment that we've missed, and therefore we have missed 3 payments. On the right-hand side, we have X as 5,500. Then in brackets, we have our I value as 0.09 compounded monthly. We don't know what N is, that's what we need to solve, over 0.09 divided by 12. Also notice on the left-hand side, I'm taking the interest rate and I'm dividing that by 12 because I'm compounding monthly, but I'm only raising it to the power of 3 because I missed 3 payments. Now, if you manipulate the equation slightly by multiplying out on the left-hand side and multiplying that result of 0.09 over 12, and then dividing by 5,500, we have on the right-hand side the brackets, which is 1 minus 1 plus 0.09 divided by 12 to the power of minus n. And on the left, we have a decimal. Now remember, in financial mathematics, we do not round up until the end or up until we have our final answer. Next, what I would do is I would move this little section in our right-hand side to the left, and I'll say 1 minus the decimal value. So on the right, on the left, I'll have 1 plus 0.09 over 12 in brackets raised to the power of negative n. Notice it was negative on the right-hand side, but on the left it will be positive. And now it's 1 minus 0.31, which leads to 0.686. And again, I'm keeping all the decimal places up until my final solution. Now, in order to find negative n, I'll take the log of my bracket, which is 1 plus 0.09 divided by 12, and the contents of my log is that 0.68. And when I simplify that, I have negative n as negative 50.39. Therefore, n is equals to 50.39. Now, the question was, how many payments will Lesibana make to settle the loan? So she's going to make 50 full payments, and then there's a little bit still outstanding. So therefore, Lesibana will make 51 payments. Thank you for watching. Remember to show your support by hitting the like button and subscribing to Mathenatic. We are moving on with question 8 of paper 1 for June 2024. 8.1. Determine the first derivative of f from first principles if fx is equals to 1 over x. So on your formula sheet, you have f prime x is equal to the limit of h towards 0 for fx plus h minus fx over h. Now in this question, fx plus h would be equal to 1 over x plus h. So we can substitute fx with 1 over x and fx plus h with 1 over x plus h. Remember, when working with first principles, to keep the limit in the front, because we have not introduced or worked with the limit just yet, and you can't make h 0 because that will make the denominator 0. So when I substitute, I have 1 over x plus h minus 1 over x over h. Now I do not want to work with this compound fraction, so I'm going to rewrite that fraction slightly. So we have the limit of h towards 0, and in brackets I have the numerator of 1 over x plus h minus 1 over x, and I'm multiplying this with 1 over h. So all that I'm doing is I'm keeping the numerator by itself, and I'm moving this h to the side. So I'm multiplying with 1 over h. Now if I simplify my brackets, I'll have the limit of h towards 0. And here, to make a common denominator, I'll have x times x plus h. And in the first term, I need an x in the denominator. So I need to multiply the numerator with x as well. So that is x minus, and then in our second term, we need x plus h. So I multiply the top and the bottom with x plus h. And notice that I'm using brackets. And this is multiplied with 1 over h. Now you do not need to multiply out the denominator, but what we can do is we can remove these brackets in the numerator. So we have the limit of h towards 0 for x minus x, which becomes 0, and then what's left is minus h. So that is minus h over x times x plus h in the denominator times 1 over h. And now you can see that the h's will cancel out. So I'm left with the limit of h towards 0 of negative 1 over x times x plus h. Now I can introduce the limit. So if I make h tend towards 0, in the bracket this will become 0. So I'm left with negative 1 over x times x. So therefore, the first derivative would be negative 1 over x squared. Question 8.2 says determine, and 8.2.1, we want to find d of dx, and in brackets we have the square root of 4x to the power of 6 plus root 2 times x squared. So in 8.2.1, I can rewrite the first term. So we have the root of 4x to the power of 6. So the square root of 4 is 2, and the square root of x to the power of 6 becomes x to the power of 3. My second term, the square root of 2 stands alone, and we multiply that with x squared. Now I can apply the rule of differentiation. So it will be 2 times 3, which is 6. And in the exponent, we subtract 1, so that becomes 6x squared. Plus, now the root of 2 is standing by itself. So we have the root of 2 times the exponent of 2. So that is 2x to the power of 2 minus 1, which is simply 1. And if you want to, you can rewrite that as 6x squared plus 2 root 2 times x. 8.2.2 says find the derivative of gx if gx is this fraction. Now I noticed I have 3 terms in the numerator and 1 term in the denominator. That means that I can rewrite gx as 3x to the power of 4 over x squared minus 4x squared divided by x squared plus 6 divided by x squared. So what I'm doing is I'm taking the numerator and I'm splitting it into 3 fractions. And I can do that because I only have one term in the denominator. So when I simplify this, I have 3x squared minus 4 plus 6 times x to the power of negative 2. So notice the last term I'm writing as 6 times x to the power of negative 2 because that will allow me to use the rule of differentiation immediately. So g prime x would be 3 times 2, which is 6, times x raised to the power of 2 minus 1. So it's simply 6x minus 0, because our middle term does not have an x, so it simply becomes 0, minus 12x to the power of negative 3. So I'm taking plus 6, and I'm multiplying it with negative 2, and that's how I get negative 12, and I subtract 1 from the exponent. So my final answer would be 6x minus 12 times x to the power of negative 3. 8.3. The equation of the tangent to fx at x equal to 1 is given by y equals to 9x minus 9. Determine the values of b and c. So when we look at fx, we can see that we have 3x squared plus bx plus c. And we know that the function of a quadratic equation is a parabola. Next, we know the equation of a tangent to fx. So the equation of that tangent is y equals to 9x minus 9. And the point of intersection, or the point where they meet, we know that x is equal to 1. So if I were to ask you, find the equation to the tangent of the curve of fx at x equal to 1, you would first find the gradient, and you would find that by taking the first derivative. But we already have the gradient of that line, and that gradient is equal to 9. So if I take the first derivative of fx, I have 6x plus b, which represents the gradient of the tangent, and we know that gradient is equal to 9. Next, what we have is the value of x. So x is equal to 1, that's the point where they meet, so I can substitute that x value with 1, so 9 is equals to 6 times 1 plus b, therefore b is equals to 9 minus 6, which is 3. So also what we can do is find the coordinates of this point. So we have x is equal to 1, and in order to find the y value, I have the equation of the line where x is equal to 1, so therefore the y value would be 0. That means inside my equation for fx, where x is equal to 1, the result would be 0. So let's quickly do that. We have fx as 3x squared plus 3x plus c. Y is equal to 0 when x is equal to 1. And that will allow me to find c. So we have 0 is equal to 3 plus c. And we can see that c is equal to negative 6. Thank you for watching. Remember to show your support by hitting the like button and subscribing to Mathenatic. We are going on with question 9 of paper 1 for June 2024. It says the graph of fx is drawn below. E and G are the x-intercepts of f. We can see that with fx we have a partial solution. We have the x-intercepts of E and G, and notice that E's coordinates is negative 1 and 0, and G is 5 and 0. 9.1. Show that A is equals to 1, B is negative 3, and C is negative 9. So I have fx is equal to ax to the power of 3 plus bx squared plus cx minus 5. So what I know is that I can rewrite the equation of this cubic function as a times x minus x1 times x minus x2 times x minus x3, where x1, 2, and 3 represents the intercepts with the x-axis. Now you would notice that I have 3 values that I consider, but in this equation, I only have 2 x-intercepts. That means that one of the x-intercepts repeat. So y can be written as a equals to x minus x1 squared, that's the value that repeats, times x minus x2. Now if I substitute my x-intercepts, I have a is equals to x plus 1 squared times x minus 5. Now the reason that I put in the plus 1 with the square, because that represents the turning point or the stationary point of E. So E equals to negative 1 represents both x1 and x2, or you can say that's the intercept that repeats because the turning point is on the x-axis. And remember, it's minus x, so it is minus 1, and that's why we have plus 1. Now before I multiply out, I can find the y-intercept. So from our equation, we can see that if we make x equal to 0, that the y-intercept would be equal to negative 5. So when x is 0, y is negative 5. And if I substitute that into my equation, I have y as negative 5, which is the constant value from our equation of fx, is equals to a times 0 plus 1 squared times 0 minus 5. And if you simplify, you have negative 5 times a times negative 5. Therefore, if I solve a, I can see that a is equal to 1. Now let us find the values of b and c. So I'm going to use this a in my equation for y. So y is equals to a, which is 1, times x plus 1 squared times x minus 5. So if I expand, I have y is equals to x squared plus 2x plus 1 times x minus 5. And if I expand further by multiplying out, I have x cubed minus 3x squared minus 9x minus 5. Then we can see that b is equals to negative 3 and the c value is equal to negative 9. So therefore, b is equal to negative 3 and c is equal to negative 9. 9.2. Calculate the value of x for which f has a local minimum value. So here we can see that the local maximum is at point E, and that means that the local minimum is still undefined, or we still need to find this local minimum. At the local minimum and maximum, we know that the first derivative or the gradient is equal to 0. So from our previous question, we have the full equation of fx as x cubed minus 3x squared minus 9x minus 5. And if I take the first derivative of fx, I have 3x squared minus 6x minus 9, and that must be equal to 0 at the local minimum and maximum. And now I can solve for x. So you can either use your calculator or you can factorize. So I'm going to divide everywhere by 3. And then I have a simple trinomial which I can factorize. So the factors of x is x and x. The factors of 3 is 3 and 1. And I put in the signs at the right places to get to negative 2. So therefore the values of x when I solve this equation is negative 1 or x is equal to 3. Now you can see that where x is equal to -1, we have the local maximum. But the question says find the value of x for the local minimum. So therefore, x would be equal to 3. So on our graph, the local minimum, we have x equal to 3. Question 9.3. Use the graph to determine the values of x for which f double prime x times fx would be bigger than 0. So it says use the graph. So let's look at our graph. So first we need to understand that f double prime x is referring to the point of inflection. Now the point of inflection is where concavity changes in our curve. And that will be the point exactly in the middle of our stationary points. So we can find the x value for the point of inflection. So the x value would be in the middle of -1 and 3. So therefore that x value is at x equal to 1. So here where x is equal to 1, we have our point of inflection, which is f double prime x equal to 0. Now you can see everything moving towards that point is concave down, and what that means is that the concavity, or f double prime x, would be smaller than 0, and to the right of the point of inflection is concave up. That means everything to the right of that point, we have f double prime x is bigger than 0. And then at that point, we have the point of inflection, so the second derivative would be equal to 0. Now the question said, where is f double prime x, or the second derivative, times fx bigger than 0? So in terms of multiplication, something would be bigger than 0 if we multiply a positive value with another positive value. So that will give me a positive result. Or when I multiply two negative values with each other, which will give me also a positive result, which is bigger than 0. So based on our graph, we can inspect to the left and to the right of the point of inflection. So to the left of the point of inflection, we can see that the second derivative is smaller than 0, which is negative. Also, that the graph of f is below the x-axis. So that means that fx is also smaller than 0 or negative. Therefore, in this section, we have a negative multiplied by a negative, which will give me a positive result. So it satisfies our equation. So therefore, where x is smaller than 1. And now let's inspect to the right of the point of inflection. So up until the x-intercept of 5, we have fx is smaller than 0 or negative because it's below the x-axis. So in this section, we have a negative multiplied by a positive, which gives me a negative result. And that does not satisfy bigger than 0. But to the right of 5, we can see that fx is above 0 or positive. So that means that fx is positive here, and also the concavity. So f double prime x would also be positive. So a positive times a positive will give me a positive result. So therefore, where x is bigger than 5. So for question 9.3, the second derivative times the function is bigger than 0 for x smaller than 1 or for x bigger than 5. Question 9.4. For which values of t will the graph of px, which is fx plus t, have two distinct positive roots and one negative root? So let us inspect our function. Here we have fx. We know that fx has a negative root and a positive root. Now the question asks for what must the value of t be for it to have a negative root and 2 positive roots. So that means that the function must intersect on the negative side of the x-axis and at 2 places on the positive side of the x-axis. So what we need to do is we need to move the graph of fx up in such a way to have positive values and one negative value. So let's look at some critical values. We know that the y-intercept is -5, and we know that the local minimum is where x is equal to 3. Now if I substitute x equals to 3 into my equation of fx, I have a y value of -32. And we know that px is equals to fx plus t. So this plus t part is only focusing on vertical movement up or down. So that means we're looking at y values. So in our graph here, I'm only going to consider the -32, which is that y value. Now can you see that if I take fx and I move it up from -5 to 0, I will have a negative root, then one root going through 0 and one positive root. And if I move it up all the way by 32 units, I'll have a negative root, and that 32 would become my positive root. So one negative and one positive. So I notice that the graph can move up by 5 units for it to reach 0, so cutting through 0, and it can move up by 32 units in order to move or have one positive root. Now anything in between that, so let me quickly draw that in. If I move up by 5, I have one positive, one negative, and one root at 0. And if I move up by 32, I'll have one positive root and one negative root. So can you see that in between a movement of 5 and up by 32, there will be a negative root and 2 positive roots. Anything more than 32, there will be no positive roots, and anything less than 5 units will give me 2 negative roots. So t needs to be between the blue and the pink graph. So that's between 5 units up and 32 units up. So up means positive, so it's 5 units up, all the way up to 32 units. And that will answer my question, for what values of t will I have one negative root and 2 distinct positive roots. So that's for t between 5 and 32 units. Thank you for watching. Remember to show your support by hitting the like button and subscribing to Mathenatic. Question 10 of paper 1 for June 2024. It reads as follows. EHGF is a rectangle. HE is produced x squared centimeters to n. That means that the distance from the line HE to n is x squared, and EH is produced x squared centimeters to p. So the line EH, the distance between H and P, is also x squared units. NF produced intersects PG produced at M. So simply what they are saying is that if you extend NF and you extend PG, that they meet at M. And this forms an isosceles triangle MNP. So this is our isosceles triangle with NM equal to MP. D lies on NP in such a way that it's perpendicular to NP. NP is equals to 4 units, so the full length of N to P is 4 units, and MD, the perpendicular height, is 3 units or 3 centimeters. 10.1. Show that the area of the rectangle is given by AX equals to 6x squared minus 3x to the power of 4. So for question 10.1, we need to find the area of a rectangle, which is simply the length times the breadth. Or I can say the length is EH times the breadth of FE. So let's see if we have enough information to find EH. EH is part of this line NP. So I can see that the length of EH is equals to 4, which is the full length of NP, minus x squared minus x squared. And that simplifies to 4 minus 2x squared. So we have the length of EH. Next, we need to find FE in terms of H. We are given that in this triangle, or that perpendicular height is equal to 3, and we know that this is a rectangle. So that means that the line of FG is parallel to the line of NP. We also know that the rectangle has 90 degrees here, so therefore the line of FE is parallel to GH, but that also makes it parallel to MD. So what I can see is that forms two different triangles. We have a smaller triangle, NFE, and we have a bigger triangle, NMD. And I need to go beyond paper 1 here to solve this because I can see I would need to prove similarity. But because this is paper 1, you don't have to worry about proving similarity. Let's just write it down simply. If I look at our two triangles, which is triangle NFE and triangle NMD, I can see that N is our common angle, so that's common. Angle E would be equals to angle D, so that is 90 degrees. So I can focus, or I can group E with D. And angle F would be equal to angle M, our third angle. So therefore we can say that triangle NFE is similar to triangle NMD. And what that helps me to do is to create a ratio. So we want to find FE. So FE is grouped with MD. So FE over MD is equal to, and let's use the x squared. So that's NE. NE is working with N of D. So NE and ND. So I want to find FE. I know that MD is equals to 3 units. So you can see MD is 3. NE is equals to x squared. And N of D, or ND, would be 2 units because this is cutting this in half. So that is 2. So that is 2. Therefore, FE is 3x squared over 2. So I simply cross multiply. It's a little bit complicated for the solution, but let's see. So the area of the rectangle is EF times FE. So we have EF as 4 minus 2x squared multiplied with 3x squared over 2. Now let us expand that quickly. So we have 4 times 3, which is 12x squared over 2, minus 2 times 3, which is 6x to the power of 4 over 2. So can you see it's 4 times this fraction becomes 12x squared over 2, and negative 2x squared times this fraction becomes negative 6x to the power of 4 divided by 2. And therefore, the area, when I simplify, is 6x squared minus 3x to the power of 4. And that is the area which they asked me to prove. 10.2. Calculate the maximum area of rectangle EFGH. So they gave us the area of the rectangle, and that area is 6x squared minus 3x to the power of 4. Now for the maximum area, I need to take the derivative of the area and set that equal to 0. So the derivative is 12x minus 12x cubed. And when I set that equal to 0, I have 12x minus 12x cubed. And I can factorize out a 12x. So I'm left with 1 minus x squared. And when I factorize further, I have 12x equals to 1 minus x and 1 plus x. And when I factorize further, I have 0 is equals to 12x times 1 minus x times 1 plus x, because the difference of two squares. Therefore, I have three possible values of x, that is x equal to 0, or x is equal to plus 1, or x is equal to negative 1. So the question said find the maximum area. So I'll test or use these three values of x in my original area equation. So when x is equal to 0, the area is 0. That doesn't look like a maximum. When x is equal to 1, I have 6 times 1 squared minus 3 times 1 to the power of 4, which is 3 units squared. And when x is equal to negative 1, I have 6 times negative 1 squared minus 3 times negative 1 to the power of 4, which is also 3 units squared. So therefore, the maximum area of the rectangle is equals to 3 units squared. Thank you for watching. Remember to show your support by hitting the like button and subscribing to Mathenatic. Question 11 of Mathematics Paper 1 for June of 2024. 11.1. Two events A and B are such that the probability of A is 0.4, the probability of A or B is 0.52, A and B are mutually exclusive. Calculate the probability of B. So when events are mutually exclusive, that means the probability of A and B is equal to 0. So mutually exclusive means that they do not touch one another. So if I have my general rule for probability, I have the probability of A or B is equals to the probability of A plus the probability of B minus the probability of A and B. Now the probability of A or B is 0.52. The probability of A is 0.4. We don't know what's the probability of B, and A and B together is 0. So therefore, the probability of B would be 0.52 minus 0.4, which is 0.12. 11.2. The items that a learner bought at a tuck shop were recorded over a period of time. The probabilities of the learner buying a sandwich, a chocolate, and a juice are shown in the Venn diagram below. So notice they give us probabilities. So these decimal values are all probabilities. 11.2.1. What is the probability that a learner will buy a sandwich? So if I look at the circle of sandwich, the probability of buying a sandwich would be all of these values added together. So for the first question, I'll have the probability of a sandwich is equal to 0.09 plus 0.02 plus 0.01 plus 0.04. And that is equal to 0.16. 11.2.2. Calculate the probability that the learner will buy at least 2 of the 3 items. So in our Venn diagram, at least 2 of the 3 items is where all of the circles or events intersect. So what I'm coloring in now is that's at least 2 options, and then the middle one would be 3 options. So the part in green represents 2 items, and the part in purple represents all 3 items. But at least means 2 or 3 items. So the probability of at least 2 is equals to all of those values added together. So it's 0.02 plus 0.01 plus 0.03 plus 0.04. And that is equal to 0.1. 11.2.3. Calculate the probability that a learner would not buy any of the 3 items. So we're looking for a value outside of these events. So what I can do is to find this probability, I know that the sum of all the probabilities inside of the Venn diagram is supposed to add up to 1 or 100%. So the probability of not any of the 3 items would be 1 minus the probability of buying one or all of these items. So it's 1 minus the sum of each of these values added together. So that is 1 minus 0.04 plus 0.02, and I just keep on adding all of the values inside of the circles. So that is 1 minus 0.43, and that means it's 0.57. So the probability of not buying any of the items is 0.57. 11.3. 7 guitar players, each with a different name, participate in a concert. 11.3.1. In how many different ways can the names of the guitar players be listed, one below the other in the program? So obviously the names cannot be repeated, and I have 7 unique names. So the answer would be 7 factorial, and that is 5,040 times. Alternatively, you could have your 7 spaces and then multiply that out 1 at a time. So it's 7 times 6 times 5 times 4 times 3 times 2 times 1, which will also give you 5,040 times. 11.3.2. After the performance, the guitar players wait backstage. There is a bench with only room for 4 to sit on. What will be the probability that the 4 guitar players will be sitting in alphabetical order from left to right? So for this question, we have a bench with 4 seats, and in the first seat we can have 7 different people. Thereafter 6, and then 5, and then 4. So the total number of ways in which people can be seated on these 4 seats would be 840 times. That's the total number of arrangements possible between the 4 seats. But alphabetical order, if you think of a class list or a name list, there's only one way in which to write an alphabetical list. So therefore, the probability that they would sit in alphabetical order would be 1 out of 840. 11.3.3. During the performance, the 7 guitar players sit in a line on stage. 4 guitar players are female and 3 are male. In how many different ways can they be seated if the males may not sit next to each other? Now this question is a little bit tricky. So we have 7 seats, and let's say we start with a female player. So it's female, 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 female. That leaves room for males in the seats in between. Now the way in which these 4 females can be organized is 4 factorial. Now think of males. We can start the line with males. Then we'll have male, female, male, female, male, and then the last seat would be female. So we can start with male, or we could have males in the second seat and not start with male. Or a male could be in the third seat and not in the first two possible seats, or in the fourth or sixth seat. Or if I don't have a male that I start with, I can end the line with a male. So if I take this male away, that's another type of combination that I can have. So what you see here is that there are 5 different types of groups in which males can be seated. So we have 5 groups, but if one male is seated, so let's say he takes that first position, then there's only 4 groups left for the second male. So that is times 4. And then obviously for the last male, there's 1 grouping left. So notice I'm speaking about groupings. So if we start, for example, with a male, or let's say this is male 1, he has 5 options in which he can be arranged. Once he is seated, the other 2 males have 4 options left, and once the first 2 are seated, our last male only has 3 types of seats that he can still occupy. And that total is 1,440 ways in which they can be organized with men not sitting next to each other. Thank you for watching. Remember to show your support by hitting the like button and subscribing to Mathenatic.